Greetings, this is M Squared, and we are going to be solving some linear systems using the method of graphing. Remember, linear means lines, so linear systems means you're going to have two lines. Sometimes it's two or more, but right now we're just going to have two lines that we are solving for. What that means is that we're trying to find the point where these two lines intersect. So remind you that three different things can happen when you're graphing lines. You can graph two lines and they can intersect. You can graph two lines and they can actually be the same line, so it looks like just one line because you have one line on top of the other. Or you can graph two lines and they don't intersect because they're parallel. And remember, parallel lines have the same slopes. The easiest way to graph, in my opinion, is to get everything in slope-intercept form, which means y equals mx plus b. You've probably been working with that. So that's what I'm going to do. If I find a system like this one where y isn't alone, I just get it alone and then graph it, because to me it's easier. So let's start with this one. Y is alone, so that means the coefficient of the x is the slope, and the constant, or the number all by itself, is the y-intercept. So if the y-intercept is 2, I go up 2 on my y-axis and make a little point. And then if it's -1, remember slope is rise over run, so that's -1 over 1. That means I go down 1, right 1, down 1, right 1, etc., etc. I could go this way as well. And that is my first line. Now this is my next one, so I'll just use a pencil so we can kind of see the difference between the two. 2x plus 5, that's my y-intercept. So I go up 5, the slope is 2, so I know I'm going to go this way, so instead of going up 2 over 1, I'm going to go down 2 over 1. And you'll notice that that point is in common, so that means that is where they intersect, which means it's the solution to this problem. I get one solution when they intersect. So my answer is -1, 3, because I went left 1, up 3. That's where the lines intersect. It's the point that is common between the two lines. So let's try this one. Y isn't alone, so I need to get it alone. So I'm going to add 2x to both sides. When I do that, I get y equals 2x minus 1. When I get y alone here, I minus x from both sides. So I get y equals -x plus 5. And so now I'll graph this line first. Remember, y-intercept, slope. Y-intercept is -1, so on the y-axis I go down 1. The slope is 2. Some people like to put a 1 under it so they know it's 2 over 1. That means I go up 2 over 1, up 2 over 1, and I connect the dots, and it'd be right there too. You should probably use a straight edge, but I am not doing that. Let's graph this line. 1, 2, 3, 4, 5 is my y-intercept. Down 1 over 1, down 1 over 1, etc. So this is the solution at the point of intersection, which is 2, 3. A lot of people just graph the line and they forget that when you're solving a system, the answer is actually the point where they intersect, the point that the two lines have in common. So this is the answer. Okay, now if you are solving by graphing and you can notice right here that the slopes are the same, then you already know there's going to be no solution. The answer is no solution. But if you didn't notice that, we should graph. So y-intercept is 1, go up 3 over 1. Probably should go this way so we can see it better. And then this one, the y-intercept is 8, so 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis, and then up 3 over 1. And I forgot to connect my dots over here, didn't I? And you see that they're parallel, which means they have no solution. Let's try this last one. Sometimes it's good to just look at them and say, so that's a 3, that's a 2, that's a 1. And if you'll notice, this is 3 doubled. 3 times 2 is 6, 2 times 4, 2 is 4, 1 times 2 is 2. That means this equation multiplied by 2 is that one. That's a hint that these are going to be the same lines. We're going to have an infinite amount of solutions because it's the same line. What some people do is they get y alone anyway. So if I got y alone here, I'd move the 6x over and I'd get -6x plus 2. When I did that, again, I'd do that over here as well. Move the 3x over. And when I divided, if I divided this by 4, I would get y equals negative 6/4 plus 2/4. And if I divide this by 2, I get y equals negative 3/2 x plus 1. Reducing, oops, I forgot my x there. Reducing these, I get negative 3/2 x plus 1/2, which you'd see is the same. I forgot the 2 over there. Sorry about that. They're the same line. So we know that they have an infinite amount of solutions, and some people use this infinity sign to just show that there's an infinite amount of solutions. And of course you could graph that. I didn't graph those. I just wanted to show you. It's kind of difficult for us to graph it when it's 1/2, 3, negative 3/2. Not impossible, but a little challenging. So I chose not to do it there. And again, if you're just finding the solution and you can recognize that either they're parallel or that it's the same line, then really you don't have to graph it, unless that's of course part of the assignment. So good luck using graphing to solve systems. And this is M Squared signing out.